teleradiology system.
Good morning, everybody. My name is João Figueiredo from Federal University of Paraíba, Brazil, and I am going to present the work SocialRAD, an infrastructure for a secure, cooperative, asynchronous teleradiology system. The presentation is organized as follows. First of all, I will introduce the motivation of this work. Second, I'll describe the methodology used. Then I will present SocialRAD in more details, followed by results, discussion, and conclusion. This work was developing regarding context with real needs for teleradiology. For real needs, we mean remote locations without assistance from radiologists or with insufficient assistance. For instance, only twice a month. And these locations generally present very poor conditions of technological infrastructure and are located in cities with difficult access, and also a lack of skilled IT staff to support critical services or to develop its own solutions. So, why we identify a need for a solution able to operate in need of specialized IT skills, even in situations of lack of proper IT infrastructure, such as dedicated internet servers or advanced dedicated internet link or advanced internet servers, and capable of operating with no association to any teleradiology company for intermediation between hospitals and radiologists. So, the general purpose of this work is develop and validate the teleradiology solution able to address this main problem, covering locations without assistance for improving diagnosis quality and handling emergency cases with emphasis in offering information security and also value to radiologists who may not see much benefits in working with close private companies. In addition, this solution aims to be publicly available. But how to reach these goals? We start with literature review and critical analysis of the last 5 years' work to identify the major deficiencies both in academic and private sectors. Once identified the main problems, we begin to build a solution using evolutionary deployment and prototyping, and based in security patterns, best practices, and free and open technologies in order to produce a reliable and low-cost solution. And among the key technologies and features of our solution, we highlight a service-oriented architecture able to provide good scalability and loosely coupled distributed environments. The solution was designed to be able to operate under unavailability of public and static IP addresses in a peer-to-peer communication behind NAT devices, with support to multi-domain authentication and authorization, and able to do this abstracting the distributed environment from the users. The entire process takes place transparent for healthcare professionals who interact in a cooperative manner in distributed environments, taking full advantage of a unified view for all available resources. It's used as security in-depth approach with support multiple layers of security, protecting information in whole life cycle, not only during transmission via SSL or TLS, but also in client and server side. And very important, our solution also provides automatic provision to make installation easy for users with minimal IT skills. From a high-level view, the workflow model is illustrated in this figure. On step 1, the imaging test is carried out, and 2, the test is sent to the local SocialRAD web service via DICOM protocol. On 3, the test is made available to the local technical operator who is able to define parameters such as the users of the test reports, the authorized doctors, and the patient's history, for example. Only the metadata of the test is sent to an external global catalog in the cloud. it is not send imaging test, but only metadata. In 5, the SocialRAD client used by the radiologist synchronizing with the global catalog and show available jobs for the radiologist. So after this step, in 6, 7, and 8, the radiologist received the tests, images in DICOM formats, directly from the hospital clinic that produced it. And in a peer-to-peer communication, abstracting the distributed scenario from the radiologists. And the final report is concluded by the radiologist, signaled for the delivered to the patient hospitals in step 8. On further consideration is the unavailability of public and dedicated IP address. In order to overcome this barrier effectively, a solution was developed inspired by the UDP Holy Punch technique and by the mechanism adopted by the Skype and based in other researches such as Internet RFCs, making wholly the process very transparent. In summary, these documents describe techniques for peer-to-peer communication between computers in Internet, even when bots are written in private network. Behind the devices perform network address translation, the NAT. The complexity of the workflow is abstracted from the end user by the SocialRAD client, this Java application. In turn, this application itself is installed and started automatically. It's only required by the radiologist to authorize the installation and perform authentication on the systems. This window shows only metadata which are stored in a local relational database cache on the client computer. That database is automatically created when the system is accessed for the first time and is written in Java in order to maintain portability. Each user has her own encrypted instance of the database with stored metadata for the test with the area authorized for the access. However, considering that doctors generally access the system from different computers at different locations, for example, the hospitals where they work, special measures are needed in order to protect such information. Thus, in SocialRAD, metadata and the exams, the DICOM files are encrypted locally before beginning stored on disk using the AES cryptographic algorithm. However, in order to avoid incompatibility with the DICOM virus, the process of data encryption is performed through a virtual disk driver on encrypted file system. Thus, any DICOM virus chosen by the doctors is able to have seamless access to the DICOM images, as if there is not encryption. The algorithm used is also the AES and mode of operation XTS, which is NIST recommended for the disk block encryption. In addition, these data are marked so as not serve the paging process, thereby prevent them from being written onto the area of the disk used for virtual memory, the swap space. This strategy aims to protect the information on client side, including protecting against computer forensic procedures. And on the server side, in order to provide appropriate level of security, multiple layers of protection are made available, each operating different security patterns. And on point 2, there is a stateful firewall with implemented a restrictive default policy. On 3, the protection reverse proxy security pattern and protocol intrusion prevent systems are implemented to perform detailed inspection up to the application layer. Element 4 contains the SocialRAD web service that enforces authentication and authorization and implement the principle of last privilege and 3T architecture. Finally, on point 5, image detection and report are stored and managed by a service that supports the DICOM standard, providing a virtual system PACS. And considering the lack of technological infrastructure in cities with difficult access, and even more critical, the unavailable of skilled IT staff capable of operating the proposed topology, full deployment of this solution can be performed on any traditional desktop computer, shown in 0.6 billions of virtual machine. Thus, the logical topology deployed on a virtual machine is available in standard open virtualization format, OVF. The installation process is very similar to a common software as the Dropbox or Skype, and can be performed by the health team itself. This figure shows the screen of the SocialRAD virtual machine on the hospital, providing the complete local PAC system and the teleradiology solution. And as a result, we have 2 locations already using and testing SocialRAD on northeastern hinterland of Brazil, one in General Hospital in Brasil Santo City in the state of Ceará, and other on São Francisco First ID Hospital in Salgueiro City in the state of Pernambuco, Brazil. Medical specialists are based about 500 kilometers away. As you can see on the map, the seats are marked in red and the doctors in green, and very long distance. Some usage metrics before SocialRAD in those cities, there were no specialized reports, and after SocialRAD in average are making 35 scan reports per day. In addition to full-time coverage of emergency cases, it is very, very important. And this of a number of patient benefits per month in Salgueiro City in Brazil. In green is number of patient benefits by the SocialRAD in Salgueiro City. And this is a number of patient benefits per month in Brasil Santo City, and green. For conclusion, we highlight the cooperative model of SocialRAD allow radiologists to interact directly with the hospitals without any intermediation of teleradiology company in a peer-to-peer communication. Also, the distribution interconnection model of SocialRAD does not require patient image to be sent to external services, being directly accessed by the radiologist with security measures implemented in all life cycle of information. In this way, SocialRAD is given directly positive social impact in such communities. And I would like to thank you for your listeners, and sorry for my very, very bad English. I would also like to say a special thanks to Brazilian Association in Health Informatics to support my presentation this paper as a prize for the best paper and at conference in Brazil. And very thank you.
Any comment and question? I have a basic question. In your system, doctors retrieve the image of the patient from the screen, or the facility could take, which takes the image, push the data to the doctor.
No, which one? Doctor could get, yes. Connecting peer-to-peer connection, doctor to the hospital and get the images. So a push-only metadata.
So the doctor in radiologist can be seeing the all the patient data. It is the risk after all the patient data in this point. So I mean for security reasons.